Namaste, dear students. Today in this lecture talk, I'll be discussing with you about paper chromatography. Okay. Before that, in your syllabus, you are studying this chromatography under the unit analytical techniques, principle and applications of chromatography. Okay. So I'll be dealing here today paper chromatography, and in your unit, you are studying thin layer chromatography, column chromatography. Okay. In column, you'll be studying GLC, that is gas liquid chromatography, and high performance or high pressure liquid chromatography. Okay. I request you all to subscribe this channel to support. Thank you. Before going through today's class, let us go through this good thought. Reverence will transform in following ways: ordinary to extraordinary, mediocrity to excellence, failure to success, whimsical to consistent, slipshod to perfect, mundane to divine. Okay. In short, to brief about this, if you have a spark within you with great desire to do good, you can become a transformer or healer. Okay, think about this. Now, let us go through today's lecture talk, that is chromatography introduction. Okay, then later we'll be going through paper chromatography. Okay, so the word chromatography, which is taken from the Greek, that is chroma, means color. Okay, and graphene means to write, is the collective term for a set of laboratory techniques for the separation of mixtures. Okay, the mixture is dissolved in a fluid called the mobile phase. Underline this: mobile phase, which carries it through a structure holding another material called a stationary phase. Okay, the various constituents of the mixture travel at different speeds, okay, according to their molecular weight, right? Causing them to separate. The separation is mainly based on differential partitioning between the mobile and stationary phase. Okay. To understand this mobile and stationary phase, we can recall the chalk. Okay. Or you can recall the blotting paper. Okay. Or waxman paper. Take a blotting paper, just dip in the water. Okay. The paper will become stationary phase, and the water which will be absorbing from the bottom and through the capillary action to the paper, no, that solution will be known as the mobile phase. So keep in your mind, in chromatography, most commonly we'll be using mobile phase and stationary phases. Chromatography, literally, that is color writing, was first employed by Russian botanist or scientist Michael Swift in the year 1900. Okay, in some of the books they mentioned 1906. You can write any one particular year. He continued to work with chromatography in the first decade of the 20th century, primarily for the separation of plant pigments, okay, such as chlorophyll, keratins, and xanthophylls. Being a botanist, he was working with the plant pigments. Since these components have different colors like green, orange, and yellow respectively, they gave the technique its name. Okay. As they were given a different color by the color different these plant pigments, he called those as colored writing. Right? Chroma means color. Right? Chromatography. Graphy means the writing. Colored writing. So the word chromatography. Now let us go through the principle. Chromatography usually consists of mobile phase and stationary phase. Right? The mobile phase refers to the mixture of substances to be separated, dissolved in a liquid or a gas. Okay. The stationary phase is a porous solid matrix through which the sample contained in the mobile phase percolates. For example, you just keep in your mind, take chalk piece. Okay. On board, will write no, take the chalk piece. That chalk you dip in the water. Okay, when you dip this chalk in the water, what happens? This chalk will start absorbing the water. Okay, as and when this water absorbed by the chalk piece, what happens? You'll be able to see the water movement in that particular stationary phase. The chalk is like that only, it's in the straight, but water, which is the mobile phase, which is moving from bottom to the top, that is the mobile phase. That the chalk is the stationary phase. Okay, the interaction between the mobile phase and the stationary phase results in the separation of the compound from the mixture. Okay, now let us go through the applications of chromatography. The chromatographic technique is used for the separation of amino acids, proteins, and carbohydrates. It is also referred for the analysis of drugs, hormones, and vitamins. Helpful for the qualitative and quantitative analysis of complex mixtures. Okay. The technique is also useful for the determination of molecular weight of proteins. Okay. This is about the applications of chromatography. Now let us go through the types of chromatography. Pay attention here. Maybe during Viva also you may be asked, okay, what are different types of chromatography, or you may get 2 marks questions. Okay. There are following types of chromatography. Paper chromatography, okay, thin layer chromatography, short form TLC, gel chromatography, column chromatography, ion exchange chromatography, gel filtration chromatography, gas liquid chromatography, affinity chromatography. Okay, one more you can make a note here under chromatography, HPLC. Okay, HPLC stands for high performance or high pressure liquid chromatography. Okay, you can write it here as one more, that is HPLC, high pressure or performance liquid chromatography. Okay, kindly make a note here, that is HPLC. Now let us go through the introduction to chromatography again. Chromatography is resolving a multi-component mixture of trace or maybe minor or major constituents into its individual fraction. Okay, chromatography may be applied for both qualitatively as well as quantitatively. Now let us go through the other definition related with the chromatography. This chromatography may be defined as the method of separating a mixture of compounds into individual components through equilibrium distribution between two phases. What are those phases? Stationary phase and mobile phases. Okay. The technique of chromatography is mainly based on the differences in the rate at which components of mixtures moves through a porous medium, which is called stationary phase, under the influence of some solvent or gas, which is called moving phase. Okay, or mobile phase. Commonly we'll be using mobile phase. Hope you understood here. One is the stationary phase. Okay, other is the mobile phase. Chromatography involves a sample or sample extract being dissolved in a mobile phase, which may be a gas. Gas may be a mobile phase, or a liquid. Some of the liquid will percolate or absorbed through this particular blotting papers, no? So capillary action. So you can also take a mobile phase as liquid or supercritical liquid. Okay. The mobile phase is then forced through an immobile. Immobile means stationary. Immobile means no mobility. Immobile or immiscible stationary phase. The places, the phases are chosen such that components of the sample have differing solubilities in each phase. A component which is quite soluble in the stationary phase will take longer to travel through it than a component which is not very soluble in the stationary phase. But they are very soluble in mobile phase. As a result of these differences in mobilities, sample components will become separated from each other as they travel through the stationary phase. Okay. Techniques such as HPLC, that is high performance or pressure liquid chromatography, and GC, that is gas chromatography, use columns. Okay. Narrow tubes packed with stationary phase through which the mobile phase is forced. Okay. Whereas in this particular chromatography, most of the chromatography you'll be using mobile phase and stationary phase. Okay. For example, paper, whereas in this case, this HPLC and GC are going to use the columns. When we recall columns, you just recall burette. Okay, that is burette, which is the circular one, right? In that burette, you are going to put the stationary phase. Okay, then to that, if you put any kind of solvent, that will become a mobile phase through which the mobile phase is forced. The sample is transported through the column by continuous addition of mobile phase. This process is called elution. The average rate at which an analyte moves through the column is determined by the time it spends in the mobile phase. Okay. Now let us understand the basic terminology of chromatography. Chromatograph means what? It's an instrument employed for a chromatography. Okay. In that, we'll always see stationary and mobile phase. So what is the stationary phase? Phase that stays in place inside the column. Okay. And this can be a particular solid. Okay. For example, paper or gel-based packing. Okay. Gel-based packing or a highly viscous liquid coated on the inside of the column. Okay, where when we use this gel-based packing, there may be a liquid chromatography. Okay, whereas in this case, highly viscous liquid coated on the inside of the column, that is gas liquid chromatography. Mobile phase, solvent moving through the column either in liquid chromatography or in gas chromatography. Eluent, fluid entering a column. Eluate, fluid exiting the column. Elution, the process of passing the mobile phase through the column. Chromatogram, graph showing detector response as a function of a time. Hope you are making note in your notebook. Okay, if I'm going very quick, kindly pause this video and take screenshot and make your own notes. Okay. The chromatographic method of separation in general involves the following step. Pay attention. Adsorption or retention of a substance or substance on the stationary phase. I hope you understood the difference between stationary phase and mobile phase. Stationary phase, that will be stagnant or immobilized condition, that will not move at all, that will be just stagnant. Okay. With the stationary phase, mobile phase, that will be usually a liquid or maybe a gas which will be moving through this particular stationary phase and carries the molecules or separate molecules based on their molecular weight and their mobility. Okay. Second point, separation or the retention of a substance by the mobile phase. Recovery of the observed substances by a continuous flow of the mobile phase, the method being called elution. Qualitative and quantitative analysis of the eluted substances. Okay. Now let us understand here classification of chromatographic methods. In all types of chromatography, separation of components of a mixture results either by adsorption or partition for the column material. Okay. Binding of compound to the surface of solid phase take place in adsorption, while in case of partition, a compound gets distributed into liquid phases. Okay, so these are some of the classification of chromatographic methods. The chromatographic methods are classified as, first one, let us go through, that is partition chromatography. Okay, This involves liquid or gas as mobile phase and another liquid or solid as stationary phase. The operation includes partition column chromatography, paper chromatography, thin layer chromatography, gas liquid chromatography, high performance or high pressure liquid chromatography. Okay, all this which comes under the partition chromatography. Now let us understand this adsorption chromatography. This involves liquid or gas as mobile phase and absorbent as solid as stationary phase. The type under the category includes adsorption column chromatography, thin layer chromatography, solid liquid chromatography, gas solid chromatography. Okay. So in adsorption column chromatography, in the column, whatever you fill, no, for example, silica gel, that will become the mobile phase and solvent will be the, sorry, the silica gel, what you load with this column, no, that will be the mobile phase. And what you run through, that will be the column which contains silica gel, no, that will be the stationary phase, stagnant, immobilized. The solvent which you pass through that column, no, that will be known as mobile phase. For example, in thin layer chromatography, as the name suggests, you'll make a thin layer of the silica, okay? And then that silica plate will be known as the stationary phase. And then the solvent will be moving in that thin layer, no? That time, the solvent will become the mobile phase. Solid liquid chromatography. The solid component will become stationary, liquid will become mobile phase. Gas solid chromatography. The gas will be the mobile phase and solid will be the stationary phase. Okay. Now let us understand paper chromatography. This is very important. Pay attention. Usually in the exam, you may get this one for 5 marks. Okay. Paper chromatography is useful for separating the mixture of amino acids, sugars, other chemicals, lipids, urea, and some drugs. As the name suggests here, paper chromatography, you'll be using the paper as stationary phase. Okay, it is used to separate and identify all sorts of substances in forensics. Okay, also narcotic drugs and aspirin can be identified in blood and urine samples. It is useful in separating complex mixture of similar compounds, for instance, amino acids. Okay, paper chromatography is a partition chromatography technique, right? Cellulose paper is supporting medium over which the solvents flow. It means the paper which is made up of cellulose, no, will be acting as a stationary phase. Water bound to the polar cellulose, okay, is the stationary phase, and organic solvent which flows over it, and that will be a mobile phase. Organic solvent will be the mobile phase, and the paper what will be which are made coated with cellulose, no, cellulose, right, that will be the stationary phase. Organic solvent moves over the hydrated cellulose fibers. As the solvent passes through an area, paper containing a solute, that is the mixture of components where you have loaded the sample, no? The solute begins to partition itself between the aqueous and organic phases in proportion to its relative solubility in the two phases. Okay, the components of the solute more soluble in organic phase will be carried faster along the organic phase. Okay, conversely, the greater the affinity for water, slower the solute will move with respect to the solvent front. Thus, if several compounds possess different solubility rates based on the kind of spotting, each will move across the paper at specific rate. which is generally different from that of any other compound. Okay, the distance the solute moves in relation to the distance the solvent moves serves as a means of identifying the solute, and it's called RF. Okay, what I'm telling here, the distance the solute moves in relation to the distance of this solvent moves, it serves a means of identifying the solute, and it is called RF. Okay, what kind of paper we'll be using in the paper chromatography? Pure cellulose paper or Waxman number 1 and number 1 paper is most commonly used modified cellulose paper like DEAE cellulose or CM cellulose, and resin impregnated papers, ambrolite are also used. Okay, these are some of the papers we'll be using for paper chromatography. The paper is made up of cellulose fibers, and cellulose is a polymer of simple sugar glucose. Okay, the polymer chain has hydroxyl groups, okay, sticking out around them. Now let us go through the solvent used in paper chromatography. The choice of solvent depends upon the mixture to be investigated. What kind of source you brought, like that, the solvent differs. Solvent system for sugars generally used is butanol, acetic acid, water in 4:1:5 ratio. Okay, hope you understood here. Now let us understand sample application. How to apply the sample? A drop of sample containing the mixture to be separated is applied on the paper as small spot. Okay. For example, if you take this any kind of paper, no, on that paper you are going to mark. Okay. For example, you take a paper. For example, you are going to take this Waxman filter paper. Okay. Once you take the Waxman filter paper, by using the scale, you are going to draw line. Okay. What I told you, a drop of sample containing the mixture to be separated is applied on the paper as a small spot about 3 centimeter, one end of the paper strip by means of a platinum wire, okay, wire loop or capillary tube or micro pipette. Okay. The lower end of the paper, okay, below the sample is dipped in the solvent. So a drop of sample containing the mixture, whatever the mixture is there with, that separate to be separated, that you are going to take by using the wire loop or capillary tube or micropipette. You'll make a one line, very light line, and you are going to spot it here. Okay, you are going to spot that particular sample where 3 centimeter from the end of this particular paper strip. Okay, now let us go through irrigation mode. Okay, what are the irrigation mode here? The technique, there are two techniques. One is ascending method, okay, other one is the descending method. In ascending technique, solvent and solute move against gravity vertically upward by capillary action. Okay, in descending method, solvent and solute moves in the direction of gravity. For example, it means this solvent, for example, here, this is the chromatographic plate. We are going to spot the sample here. Okay, we are going to spot the sample here. The solvent which moves from the bottom to the top, right? In some cases, what happens here, you are going to label like this only, but you'll reverse and you are going to hang here, and at the top you will be having the container where fluid will be there, that is solvent will be there. From this particular, from top to bottom, this chromatography paper will be hanged. Okay, and we can see the two different types of paper chromatography technique. That is, in ascending technique, solvent and solute move against the gravity, that is vertically upward, okay, by the capillary action. Whereas in descending method, what happens? The solvent and solute move in the direction of the in the opposite direction of the gravity. Okay. A third method called radial development technique. Here, the sample mixture is applied at the center. For example, if this is the Watsman filter paper, we are going to load the sample in the center in the circular form, and this will spread like this. Okay. And once they spread, you are going to get the radial or circle shape will be able to obtain over there based on their mobility of the solid. Here, the sample mixture is applied at the center of the paper and it moves outward. Okay, it moves outward radially, forming concentric circles of increasing diameter. Okay, it will go on increasing, go on increasing, go on increasing. Ascending methods gives best results. Okay, it takes 40 to 90 hours for complete run of the solvent. Now let us go to identifying the methods. The sample compounds are identified easily. Okay. If the chromatogram is colored, if it is colorless, the paper is sprayed with suitable color producing agents like ninhydrin method for the estimation of amino acids, silver nitrate acetate solution, sodium thiosulfate solution, etc. Other methods of detection are by fluorescence and radioactivity, etc. Okay. Here you could see the representation of paper chromatography. In short, you can also call this as PC, that is paper chromatography. As you can see here, you can see the paper, right? This is the paper, right? You can see here, this is the paper, that is Watsman filter paper that has taken here. And after taking this, what they have done to this paper, they made a spot. Okay, by drawing the one particular line, they made a spot on top of this one that is outside the container. Okay, they took and they put the sample here. Here one sample, here one sample, and here one sample. So three samples they have put. Once you put this all these three samples, you are going to place the chromatographic paper within this container or closed container. Here you can see the solvent, and here you can see this will be all known as solvent front, and this will be the paper. Okay, it is the Watsman filter paper. Okay, see here you can see the clip. By using the clip, this particular blotting paper or Watsman paper we are holding, right? In this case, what happens when you dip this particular paper to the solvent will start moving to the upward directions. Okay, and you need to make a label also here 1 centimeter below the 3 centimeter below upper region. Okay, the 3 centimeter from the upward region, you need to draw line. Okay, to draw a line. Once the solvent reaches to this particular solvent front, no, then that will be taken out. Here you can see this will be closed container only for you to show it is this particular container open. Here you can see the chromatographic paper, and here also you can see the chromatography paper. Okay, here the by using the tape they have fixed here. Okay, or you can also use the clip, whatever is available in the laboratory. Okay, at the bottom you can see here the solvent. Okay, this solvent will be absorbed by the paper. The absorbent is a sheet of paper or waxman paper of suitable texture and thickness will be taken. Development may be ascending, okay, in which case the solvent is carried up the paper, okay, which is carried here. The solvent will be carried up the paper by capillary action or forces, okay, or descending, okay. You can also see descending. In such particular case, descending, what happens in the upper region, you'll be having the container, okay. From this container below, there will be a rod, a small rod will be there, and they'll close the container, and the particular paper will be hanged like this. Okay, it means here the mobile phase is from top to bottom, not from the bottom to the top. Okay. Development may be ascending, in which case the solvent is carried up the paper by capillary forces, or descending, in which case the solvent flow is also assisted by gravitational force. Paper chromatography. The paper is suspended in a container whose lower end is dipped in the solvent. As you can make out, okay, this is the paper. Hope you are able to see here. This is the paper. Kindly make a note or make a sketch, then only you will keep in your mind. Otherwise, you'll forget. Okay, this is the paper. Okay, and when you take the paper, always you need to mark from the 3 centimeter above first. Okay, just I'll tell here. You'll take a paper. Okay, first you just imagine this is the paper. First you take a paper and mark by using the pencil very lightly, or by using the scale, or by the other end of the scalpel. Just mark. Okay, 3 centimeter gap you'll give here, and here also you are going to mark one line below the 1 centimeter. Okay, after marking, these are the spotting region. Okay, this is the spotting region. So what are the mixture is available? No, you need to spot by using the capillary tube or using the micro pipette. Spot here. After spotting this chromatography paper, this paper you are going to place in the container. Okay, that container may be a rectangle container or maybe a coupling jar you can use. Okay, and this paper you are going to place in this container by using the clip, holding clip. Okay, you'll take the clip and you are going to put it here. Once you place this chromatography in this container, bottom there is a solvent, right? Here, in this particular container at the bottom, you have this solvent. You need to see that the solvent should not touch this particular sample. It means the sample, whatever you have loaded here, the sample should not directly come in touch with the solvent. Okay. Once you keep like this, what happens? And once you cover this lid of the container, then what happens here? What are the solvent which are present here? To this paper, they will start moving upwards. Okay, they'll start moving upwards, right? Like ascending order that will start moving upward, right? Through capillary action. Hope you understood here. Here below you can write this as the solvent you can label, and this you can write as the baseline, the first line, beginning line for the particular running race. Okay, and here we have loaded with the sample. Okay, as and when we keep this particular paper in the solvent start moving through the capillary paper, this particular chromatography through the capillary action, then or you can make out even the sample also will be carried out by this particular solvent. Okay, then the movement based on their molecular weight, the movement of the particular components or solid which are present in the solution can be separated. Okay, based on the molecular weight which are very heavy that will settle here, and very light molecular weight they'll move further. Okay, you can see this is the movement of compounds, whereas this is the chromatographic paper, that is the Watsman filter paper. Okay, hope you are able to understand here this particular diagrammatic representation. Kindly write this diagram and below write paper chromatography. Okay, this is the sending paper chromatography. The paper is suspended in a container whose lower end is dipped in the solvent. Make sure the spotted line should not dip in the solvent. Okay, mixture is applied on a spot above the solvent level. Okay, this is the solvent level, above the solvent level. As the solvent slowly moves up, the paper, the different compounds of the mixture is carried upwards with it at different rates. In this way, compounds of the mixture are separated into different spots on the paper. Okay, whatever the sample we have loaded here, this will be when this solvent moves up. While moving this particular solvent, which also carry the components, okay, from this particular sample loaded, and take that one to the further region. Okay, so in this way, the components of the mixture are separated into two different spots on the paper. Hope you're able to understand. Now let us go to the RF values. The distance traveled by a particular compound is constant for the same type of paper used, okay, and same type of solvent used. The distance traveled by a particular compound will be the same. The distance traveled by a compound relative to the solvent is called RF value. For each compound, it is calculated as RF is equal to distance traveled by a compound divided by distance traveled by solvent. For example, if one component of a mixture traveled 9 centimeter from the bottom to the up from the baseline, while the solvent traveled 12 centimeter, then the RF value for that compound is. So for just imagine the RF is equal to distance traveled by a compound. I got a 9 centimeter, and distance traveled by a solvent, I got 12. Then what is the RF value? RF value is 0.75. So what is this 9? Distance traveled by a compound. When you take a chromatographic paper, your particular sample travel for how long, okay, you are going to measure. For example, if this is the paper, okay, here you have marked for the sample, and for the solvent also I have marked. Solvent should not go beyond the chromatography, right? So after spotting here, this particular spot will be taken by the mobile phase. Okay, whatever the mobile phase will be there, no? The solvent one, the solvent which will also take this particular sample upward. So while taking these upward based on the molecular weight, so the pigments will settle here only. Okay, here only, like that they will settle here. They may move like this, or they may move like this. So you through this, and how we are going to get, first you are going to take the mark. So this is the solvent front. Okay, so once this solvent moves in a wet condition to this level, we need to stop this particular experiment. Okay, and then we need to measure the distance traveled by a compound. Okay, this is distance traveled by a compound, okay, divided by distance traveled by a solvent. What are the solvent which has flowed up to here, no? Right? And this will be your distance traveled by a solvent. The paper chromatography is a technique that involves placing a small dot or line of sample solution onto a strip of chromatography paper. The paper is placed in a jar containing a shallow layer of solvent and sealed. As the solvent rises through the paper, it meets the sample mixture, which starts to travel up the paper with the solvent in an ascending order, right? The RF is equal to, I've already told you in the previous slide, distance traveled by the substance, distance traveled by the solvent front. The RF value helps for the quantification of unknown samples. Sometimes it is rather difficult to separate a complex mixture of substances by a single run with one solvent system. Okay, in such a case, a second run is carried out by a different solvent system in a direction perpendicular to the first run. This is referred to as a two-dimensional chromatography, but I'll not be focusing on two-dimensional chromatography. If you want, you can go through that particular two-dimensional chromatography. Okay, if the two spots travel by the same distance on the paper, they are most likely to be same compound, but not always, as these two different compounds may have the same RF value. The position of the solvent found in marked with the pencil before the paper dries up, means once the solvent start moving in the opposite direction. Okay, if they call again, the people should not throw that particular paper. Okay, they should keep with that with them. It means immediately, if the two spots travel the same distance on the paper, they are most likely to be the same compound, but not always the two different compounds may have the same RF value. Okay, I'm sorry. I skipped this particular sentence. The position of the solvent found is the position of the solvent front, okay, front is marked with pencil before the paper dries up. Okay, and you keep the paper in the container where solvent is there, and there was a ascending chromatography, that solvent started moving upward. Okay, and from the top to bottom I have marked one line which is you need to stop that particular reaction. Okay, so before reaching the uh, uh, end of the paper, we need to stop the reaction. The spots on the chromatogram are colorless as in the case of amino acids. Then chromatogram is sprayed with ninhydrin, which gives amino acids or any kind of compounds brown or purple color. Other coloring agents are silver nitrate acetone solution, sodium thiosulfate solution. Other methods of detection are fluorescence, radioactivity, etc. Hope you understood today's class chromatography introduction part and paper chromatography. Stay tuned with me. I'll be back with some more videos. I, Dr. Pratibha K, signing out for today until we meet again. Thank you for watching.